So, ladies and gentlemen, Stringer is here, and today we are going to go over what the actual week was. First, we started off the week with prepping the infrastructure, so Tuesday and Monday were just gluing and all that kind of stuff. On Wednesday, we have actually did a burner test, which went pretty well, and extracted pretty valuable lessons. First of all, we did learn that the pilot is very sensitive to air, so therefore we should run the and start the fuel injection with fuel rich inside pilot doesn't get air first, and then we step up the fuel, but inverse, we actually pump the fuel so that we have a bit more fuel than we need, and then we increase the air when the flame is nice and long. And basically what that does by adding air is that we reduce the flame, but we increase the temp and the intensity of it, so therefore we have a cleaner burning in a shorter duration. And based on that, I have decided that the barrel that we have in the garden is going to be a good first prototype for the burner house. Basically what this does is that we have the flame length determines how long the burning chamber should be, because we need to have some extra like safety margin or safety space in the back of the burner, so that we are able to run it safely for not to hit the wall and create impingement and fuel droplets and all that kind of stuff there, and cooling, which is dangerous because it can ignite. So the main point is that we have decided that we want to have a burner chamber that we can test and extract data from, because when we just burn the flame in the open air, in the ambient air, we cannot test pressure, we cannot test heat, and or like log all these and measure these. So we need an enclosed body or enclosed chamber that we can do and collect all these measurements that are going to be on the first hand. We're going to measure one pressure, I think, and two temperatures, one at the end of the chamber and one at the chimney level. So it's a bit above the chimney, so it's going to be in the chimney, not at the beginning of the chimney. First, not pressure sensor, we are going to use just a manometer to know that if but first, what range of pressure sensor do we need, and second of all, we don't want to damage the pressure sensor that I already have, which is only like a 2 kilopascal differential pressure. This also needs to be like a absolute pressure, not just a differential pressure, because I can't use that. Friday, when I went to the capital and grabbed a lot of parts, I have grabbed a hot air workstation and all the stuff that I have ordered. Bought a new scale, a lot of new stuff, and then on Saturday we started to clean up the barrel. That I wanted to do it with sodium hydroxide solution, like 2 to 5% sodium hydroxide solution. But when you have like 10 liters of wash water, basically, first start, why do we need this? Because the barrel contained, even if it contains oil, but this contained diesel that we had to drain, and we drained it and on Thursday, and then did the washing on Saturday. Basically this allows us safety, or lets us have safety, because the diesel in itself is not flammable, but when it starts to vaporize, it can ignite and it can cause a explosion inside the barrel if it is like well throttled down, meaning that even if you have an exhaust port on it, if it is small enough, then it can detonate the whole thing, which is not what we want actually, because you don't even need to have sparks from like an angle grinder. You can have a drill that can heat up the steel to a temp that the diesel can auto ignite at, basically. So we don't want that. So therefore we needed to clean the barrel, and first took off the barrel of made a ramp at Thursday to drain the liquid or the diesel out of it. Then decided not to use this sodium hydroxide that I first wanted to use, because when you have 10 liters of wash water, or 10 to 15 liters, and you want 2 batches of that, that's like, let's say, roughly 30 liters. And if I aimed for, I think, a 2% wash, that was 600 grams of sodium hydroxide use, which is quite a lot and cost significant compared to just that. I'm just going to decant it out to the trash basically. So I have decided to use a lighter and a more gentle, but a more reliable, or not reliable, but a more readily available material, that is ash. Basically created ash water, which is a caustic mixture. It can be really caustic, like 12 to 13, and which is consisting of potassium hydroxide and potassium carbonate. Those are the two things that it consists of. The potassium carbonate is the most of it. This can mix with the diesel and create kind of like soap, that they basically used ash to create soap for a very long period of time in back in the day. So why wouldn't it work? And I mean, it did work well, but needed to clean it with 2 times. Still have a mild diesel smell of the barrel, but it was fine to cut later on. Put the bung in, then roll it up the garden and back down, so that we agitate this solution inside the barrel. Then drained it, poured in water, clean water, hot water. Basically both was hot. Aimed for like 12.10, I think. Yeah, about 40-50 degrees Celsius water, both in the hot water and with the ash water as well. So yeah, did this. So the ash water agitation, then drained it, then put the fresh, like clean water in, agitated it, drained it, and did this one more time, except the second time I didn't clean it with the fresh water. I didn't really give a fuck about it. So took it and then basically started to mark out the cut on the side of the barrel, and then basically started to drill it out, then mandrelled it around, cut the hole. Then I realized that I miscalculated the thing, so it was fucked. So I needed to remeasure it and enlarge the hole so that we are centered. I did that on Sunday, and then cut the hole, and then started to create a flange, basically, which is used in industry. It's not that fancy. They use a thicker material, probably like 10 millimeters or 5 millimeters, very thick material, so that it doesn't warp when you basically weld it. Because the thinner the material, the more prone it is to like warping and becoming like a sombrero, that it has this nice little warpy edge. So yeah, the created the circle. Basically took 3 pieces of 2 millimeters steel, welded them together in like a T arrangement, and then marked out the circle, put a point in the middle, compass, drew 2 circles, which were like, I think, 180 millimeters for the big, and the smaller one was, I think, 60 millimeters. But then again, I have fucked it up, because then I realized later that the inside diameter that we put the burner into, basically we weld this onto the burner, so that the burner throat was not 60 millimeters, but actually 47-8 millimeters. Then when I realized that on Monday, I had to make a washer so that the basically it doesn't sit as far into the hole, the burner, and that allowed us to, I wanted to make it flush with the mouth, but turned out that I made it too big again. So we have, I think, 10 to 15 millimeters of protrusion into the drum, but that's fine. But I didn't want to redo it once again. So then I took the washer, welded around the flange material. Then I hammered both of them out because they warped again. And then I welded the whole thing onto the burner, and then Yeah, that what I got to. Will continue making some templates, and that basically I will be able to drill, and between the flange basically we will have an overlapping edge between the flange and this is barrel material, this is the flange. We have about 25-ish millimeters, so that we can put a ceramic rope there that can be when we take the bolt into it or screw into the edge, we basically tighten that and compress the ceramic rope that squishes and compresses, and that allows it a airtight seal against the thing. Besides that, I was actually progressing with the Planetary a lot. Printed out a lot of parts and designed quite some time. Did a lot of streams, as well as like I'm printing the house right now. We're going to progress with the burner probably next week. I want to have a flame test inside the burner, and I think by midweek I think I will be able to do it by then. So Tuesday or something like that, I will be able to set up the whole thing, wire everything, and then we will be able to do a test outside. So yeah, one more thing. I have actually was doing the blower mopping artifact, that basically I've write like a total document about it step by step, and the most important lesson that I have learned that is that, I mean, I knew it but I didn't implement it. You need to save always like a separate version from that you start. Basically, when you create the thing that you write today, let's say I'm writing new lines into the document or the new pictures, then I create like a V2 version of that, so that I will be able to use that tomorrow, and we will have these step by step, because I only did have one, and unfortunately for some reason I didn't pay attention. I was adding some new code, and I Ctrl+8 the whole thing, pasted the whole thing in, and then saved, and everything was gone. Basically, like I think 15-20 days of worth of work was done. And sure, thank God I didn't edit the pictures there, so I have basically took like the pictures in a different software. I use Paint 3D or something like that to create the pictures, so thank God those were actually saved, and I didn't lose those, but the wording and the writing of the whole thing was actually lost. So yeah, big lesson learned here, and I think this was it for this week. So thanks for watching. Do the hard work, especially when you don't feel like it. Mwah.